Hello, welcome everyone. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs Stratton Energy Solutions. And today what we're going to be talking about is battery energy storage and generator integration. So I know a lot of times in my old off-grid days that a lot of off-grid systems would have both a generator and an energy storage system, right, to get you through the dead of winter. But now there's definitely an opportunity for us to add a generator or even add an energy storage system to a generator on a grid-tied system. So we're going to talk a little bit about how we do that, why we would do that, and then kind of briefly go through some of the products that allow you to do some of that. I'm joined today by John Cromer, one of the head trainers at Briggs, at Solarc. Welcome, John.
Hey guys.
So really quickly run through our agenda. We're going to just kind of introduce Solarc as a company, introduce Briggs & Stratton Energy Solutions as a company, quickly talk about market drivers, and then kind of get into the meat of it. We're going to talk about the differences between battery energy storage and generators, why you might do one or the other kind of separately. We're going to then talk about the benefits of why we would necessarily combine those two together, why we combine them together, talk about the products, and then we're going to talk about additional training opportunities. There's a lot of great stuff to learn, not only from here at Briggs & Stratton Energy Solutions, but also from Solarc University as well. This is a course that allows NABCEP credits. So at the end of this presentation, I'm going to be popping up an email that allows you to email us and request your NABCEP certificate for that continuing education credit. If you do have any questions during this chat or during this talk, please put them into the Q&A function. It's a little button at the top or the bottom of your screen. One fun upcoming event that I always like to attend is the RE Plus. It's coming up in September at the Anaheim Convention Center. Both Briggs & Stratton Energy Solutions will be there, as well as Solarc. And I got a picture up there of last year's talk where we actually did host some in-booth training with Solarc. So really excited to be there. If you're going to be there, let us know, email us, and I'll make sure that we have a hat or a shirt or something for you, something special. And we'll also take a little bit of extra time to talk to you at the booth. So John, would you mind just introducing a little bit about Solarc and talk a little bit about your history and where you guys are positioned?
Sure. And apologies, my camera's not coming on, but I assure you this is a real person behind the microphone. Solarc, has been the pioneer of hybrid inverters. Our 8K was at the time by far the largest form factor that combined solar and the grid and a controller and the battery hookup and just everything you needed to power an essential loads panel easily. And we really had the 48-volt battery market to ourselves for a number of years because the larger platforms like Enphase and SolarEdge only have recently really launched their battery product. So our fundamental system architecture, the transformerless hybrid inverter, we have almost 8 years of field experience with that architecture, and we've since expanded it into the commercial space as well. So we kind of occupy a first to market position with a small commercial ESS solution. So we have a pretty expansive product line in residential and commercial.
Thank you, John. And one thing I would add about Solarc is, in a lot of ways, the Solarc product lineup is one of the perfect items to integrate generators. We're going to get into some of those reasons why, but it's really unique in the sense that you can take in solar, you could take in the grid, you can take in a generator and use that to create a very resilient and potentially, a system that will pay itself off relatively quickly. So that's why we're really excited to partner with them. Briggs & Stratton has been around a long time, over 100 years. So we have a great amount of capital and a great history in our company that allows us to be innovative and be service oriented with our products. So not only do we do energy storage systems, but we also have generators. So by combining both these batteries and these generators and then using that solar, we really can create very successful systems. We're a truly global company. So that allows us to really have partners all around the country, all around the world that we're able to leverage for our development and our capabilities. One thing I also want to mention is not only do we make energy storage systems batteries for residential and commercial use, but we also make batteries that are used in power equipment. And we're seeing that kind of develop. And so we really have expertise in both on our Briggs & Stratton side. And that being said, right, we're able to be two American companies that have come together that can provide that US-based support, that US-based presence, and then provide a system that really gives you that resiliency, makes it easy for the install, and gives the homeowner something reliable and to operate with. What you're seeing on the screen right now is a solar inverter coupled up with our 6.6 stacking battery. This basic battery setup, right, is a 20 kilowatt hour setup. There's each of those stacks is 6.6 kilowatts. You stack 3 of them up and you're at 20 kilowatt hours. You can then add additional stacks to build up that energy. And if you necessary, you could also add additional inverters to scale up that power. So by having the inverter and the energy storage decoupled, you can scale those separately and build up to the size system that you need. Now, we're going to talk about generator optimization. That's there at the bottom, but recognize that these energy storage systems with generators also provide the backup power, right? Unlike a generator, which is kind of just sitting there waiting for an outage, by having an energy storage system, you really kind of create a grid interactive device. So you can, if you're in an area that has time of use rates, you can kind of buy low, sell high. If you were to add solar, you can charge up the batteries during the day, cover the home loads if you have a little excess, and then discharge the batteries at night. This is becoming very common in parts of the country that are implementing new interconnection policies or net metering policies that really don't give you anything for your solar production as you're backfeeding to the grid. But when you buy from the grid, you're still paying that retail rate. So we're seeing that here in California under NEM 3.0. So by having an energy storage system, it's really, I think of it more as a grid interactive appliance. I was just out at Midwest Renewable Energy Fair, and I asked the question: are still people doing small wind? And if anybody is in this call that is still doing small wind, I would love to hear it. Solar is capable of taking in some of that small wind power, but really what we've seen with the reduction in the PV photovoltaic modules is a lot of times people are just adding PV systems, but it was interesting to hear that that's still possible. And it is something that I would like to see. If anybody has done that, put it in the chat and let us know where you're at. Off-grid has definitely been a system that a lot of people got their start on in this industry. That isn't as big of a market anymore, but that's not to say that both Solarc and our Briggs & Stratton energy storage batteries plus our generators can't be leveraged in off-grid systems. While we're here, go ahead, John.
We have lots of customers living off-grid with our systems, and you can get away living off-grid with storing maybe even a day's worth of energy as long as you have a generator. So the combination of the two is there. We get into some really advanced configurations because off-grid customers, they all are very well researched, and with wind integration, what's neat is that you can do it simultaneously on a solar MPPT. It can be reprogrammed for a wind turbine. And while the vast majority of our customers don't do things like that, we kind of feel like, well, if we didn't do it, then there wouldn't be a solution on the market for it. And so that off-grid background is why we have generator controls and generator hookup built into the inverter. And then it's not that simple. You also have to support it because not all generators are equal, and so having a residential solution, that will work for the customer is something that is important. Um, and beyond that, we have very extensive feature set for off-grid customers.
Yeah, and we're going to dive into some of those on this talk. I know that you, John, have done a number of these talks as well. They can be found on the Solarc University, where we dive in a little bit deeper. One thing I've been excited about is when you lived off grid historically, it was propane was kind of the dirty little secret of living off grid. Propane for your heat, propane for your water heater, propane for cooking. With the advent of these energy storage batteries, these very energy dense lithium ion chemistries, and the advent of much more larger inverters, living off grid doesn't necessarily have to feel like living off grid anymore. And frankly, when the grid is down on in your neighborhood home, that's exactly what you are, is living off grid. So we're able to support that system definitely, and I'm excited to hear that we're still supporting the wind. So kind of just to level set us, what does a generator system typically look like? What you have on the left there is essentially what you would see, right? You have the grid, you would have a meter can, and there should be actually a service disconnect here. Sorry about that. You go into a transfer switch, and then during a grid up situation, all of that energy is flowing right into the power is flowing right into your load center. When the grid goes down, the generator will automatically detect the loss of grid, start itself up, then send a signal to transfer to go ahead and transfer that transfer switch. Now what we're doing is we're feeding the generator power through the transfer switch into the load center. That's crucial, right? We need the transfer switch because the last thing we want to be doing is backfeeding the grid with our generator power, potentially putting the linemen down the road trying to get the power back on into the neighborhood in danger. Now, if we look on the right-hand side, what's kind of taken place of our transfer switch is the solar, right? Remember, the solar essentially has, it's not called a transfer switch. I think it's a MIDI, or a micro interconnection device, is built into the Solarc itself. So now the Solarc is functioning as the transfer switch. So in the same sense, we have grid coming through the meter socket, going through a disconnect, flowing right through the Solarc, the pass-through, if you will, into our load center. If the grid goes down, the Solarc is going to detect that, disconnect us from grid, but it's not necessarily going to start the generator up right away. It's going to be looking at the state of charge of the battery, or how much energy is left in the batteries, and only when it needs to then start up the generator will be called upon when the energy reserves in the battery start to drop. So it's a much more dynamic system. And then additionally, this could be solar, could be added to the system. As John mentioned, also wind as well. So we're adding a lot more ability to control where and when power is flowing. And as we're going to talk into a little bit into the details, why necessarily that's going to be the case. So as somebody who's dealt with a lot of generator dealers around the country, a lot of generator dealers, we kind of think about power. We think about whether it's a 13K generator or a 20K generator. One thing that I had one of our trainers on the generator side of things kind of come up with is this slide, where it kind of allows us to think of the batteries as a fuel tank, right? How big is your fuel tank? So that's energy. Whereas we're thinking about how much power we need to maybe start a load or provide power to the lights in the house. That's going to be your engine. And John, you had mentioned in a training the other day that really the power is less of a concern than it has been historically in energy storage systems. Why? Because our inverters, the Solarcs, are becoming larger, and you can it used to be the old kind of trace inverters or some old Magna signs, whereas now with the advent of these larger inverters, that's not really the limitation anymore. Additionally, inverters haven't historically always been able to be parallel. Well, we can parallel up inverters and combine them together to provide the extra power we need. So really the focus in a lot of ways is coming back around to energy and how much fuel is in that fuel tank. John, anything to add to that?
Well, let's take the Solar 12K and even the 8K, which came out the year before it in 2018. These are inverters that you can still buy today and use to expand your system. And so the power need, the power design process can be as simple as just leaving enough space on the wall for a second inverter. And if the customer ends up needing it, you add it. And I know that's not like a conversation all installers want to get into, but when it comes to like what is the actual solution if you undersize your system in terms of power, it's just, well, you needed a second inverter. But when the grid's online, with that grid pass-through capability, any additional power comes from the grid. And when the grid's offline, that's when customers pay attention to how much power and energy they're using. So as long as they're starting off with an inverter that's large enough to power a water pump and a central air conditioner unit and some lights and whole home backup, as long as they're not doing anything like crazy intense with their home, it's just a matter of, do they lose power a lot? If so, well, maybe you go with the second inverter. But if their grid's pretty stable, it's a matter of, well, they'll pay attention when the power goes out to their energy use, and they just, whether it's load controlled actively or not, they'll be able to ride through that power outage in comfort.
That's a great point. Yeah, and that was something I missed there, John, is that load control is becoming much more common, much more affordable, and much easier to integrate. That's going to allow these systems. And what I really like, yeah, leave the space on the wall, but maybe also buy. A lot of people use gutters or wire troughs. Buy that extra little bit longer wiring trough so that you can just slap a new inverter up and then kind of stub down into that wiring trough. Thank you, John. Um,
Yeah, and the
yeah.
load control, just one more thing, and sorry to interrupt, but you said load control has never been easier. It's like now you can go on Amazon and get single device load controllers that communicate with Alexa and Google Home that are listed that could run electric water tanks. So, it's really, load control is as simple as putting your water tank on a smart relay, which costs $130. And during a power outage, you turn your water tank off. And now you can run as much air conditioning as you want. And when you want to, hot water, you turn your air conditioner off and heat up your water tank. So we don't need to overthink load control. It's never been more affordable and easy. And really, when it boils down to it, if you just put it on your hot water tank, that's really all you need.
Yeah, exactly. And since we're talking load control, you mentioned one, right? You can manually use an app to turn off on load or turn on a load. And we'll talk about it a little bit later, but the Solarc has the generator port, can also be a smart load out where, and
And
we'll talk about how you can use that a generator when you're using up the generator port for smart load out. But that load port can dynamically drop loads based on the energy reserves of the battery. There's additional load controls that can also drop loads based on power if the loads exceed the amount of power that necessarily will be pulled. So on this slide, we're kind of looking at whether you got a homeowner and they're thinking whether or not they should do a generator or maybe they should do energy storage. Mr. and Mrs. Homeowner, I'm not sure which one to offer you. So let me walk through some of the pros and cons. One of the pros of generators is really you have an unlimited fuel supply. A lot of times people have a big 500 or 1,000 gallon propane tank on the property, or they're on natural gas, which is essentially unlimited. A lot of times generators are lower upfront costs. Now that's not always the case, especially if we have to start running a lot of gas lines and maybe your gas meter is on the other side of the property and we got to do a lot of piping and plumbing to get that gas lines over. When I say not dependent on solar installation, what I mean by that is not necessarily whether it's cloudy or it's nighttime. I'm more referring to this kind of map behind me that we have to understand in winter, you're going to get a lot less solar insolation or sun hours in the winter than you do in the summer. Whereas a generator isn't necessarily going to be hindered by that amount of sunlight, whether nighttime, whether cloudy, or whether during the winter. Kind of wrapping up this slide deck at the end, we're going to talk about fuel costs. Now, the average price of propane and natural gas in this country is only going up. And if you have one of these generators that's using 2 gallons or 3 gallons of fuel an hour and you're spending $2 a gallon, those fuel costs can definitely start to come up. And we're going to talk more about this as we come up about why you can use energy storage to charge up the batteries. I mean, using a generator to charge up those batteries and shut the generator off. One thing I've always noticed is maintenance costs on a generator. Now, there's oil changes, there's air filters, there's valve adjustments, and a lot of times generator installers will base a lot of their income on these maintenance packages. Now, there is still opportunities to do maintenance on energy storage, but as I'm pitching this to a homeowner, I will definitely mention, it's going to be less cost. Installation location, that is going to be dictated on necessarily where those gas lines are and whether you want the generator pointed towards your neighbor if you don't like them, or maybe somewhere else if you do like them. Noise is always a concern of generators, and also fumes. There was not necessarily the fault of the generator manufacturers, but installers installing generators too close to openings in homes and causing carbon monoxide poisoning on people's houses. Down to energy storage. Somebody that's looking to go energy storage, I'll pitch it this way, necessarily, it's kind of an eco-friendly design. It can be more of a grid interactive device like I talked about. It is eligible for that 30% tax credit. This is something, John, maybe you've heard of, is the small inconvenience of having to reset your clocks, right? With a solar inverter, you have like a 5 or 8 millisecond transfer time. That's so quick that you're not even going to notice it. You're going to notice it maybe if you look out the window, or you're going to get an alert on your app, but your inverter, the router in your home isn't going to reset. All of the other clocks in the house aren't going to reset. So
Yeah,
it's
this
a
is
small perk.
right. This is the UPS grade transfer time, and it's not easy because it's absolutely what customers want. They don't want to lose power for like 5 seconds or 1 minute and have to reset those clocks and hear their devices go on alarm and all that. They want the UPS speed, but that requires special considerations, and basically heavier duty relays and items like that. And Solarc has been through we've been through all the tests. We've gotten the field experience with our smaller inverters. The 15K has that grid sized for 200 amp service port connection to it. That microgrid relay is quite large, so it delivers what customers want in the form factor where it's all included in one box. And normally, with other whole home backup systems, you would have to include an AC combiner panel or a meter collar, whereas this is just included in the inverter that you're already installing.
Yeah, and that's kind of brings me to one of the cons of energy storage historically, is that you would have to relocate loads. And with that Solarc 15K that John just mentioned, right, we can take 200 amps, which is your typical residential service, take 200 amps from grid, put it into the Solarc, and then come right back out and back up an entire home's panel. So you're not having to relocate those loads. And I say potential, there is some considerations to that. If we wanted to do a partial home backup, we would with some of the smaller models. And then if you have a meter main, which is kind of common here in California, there may need to be some relocations of loads. So what are the advantages when we combine them? Of course, you're going to give yourself more energy resilience, right? If the batteries are drained and you don't have solar to recharge the batteries, we can start up that generator, charge the batteries, rinse and repeat. One thing, and this is kind of the big one, is a lot of our generators, and I've talked to a lot of generator installs, we have a histogram inside of our generators that will tell you the load at which the generator has been run at for its life. And a lot of times we size bigger generators to start up motor loads and the like. But really, when you're just kind of running, a lot of generators are running at a quarter load or even less, just to kind of keep the lights on in the home. And we have that big generator to start up those bigger motor loads if necessary. So what we can do with energy storage is we start up the generator and run it hard. We run it so that we're running it at its kind of a more fuel efficient point, and we're going to be able to use that generator for just maybe 2 hours and charge up those batteries and then shut the generator off. That's really going to save us on the fuel. And that's going to equate to cost savings, but also if during a crisis, fuel may be more difficult to get, right? You might not get a propane truck down the road. When that generator does start up, it's going to take over the support of those loads and then be able to charge those batteries up. So I took a couple of wiring diagrams out of the Solarc 15K manual. What we're looking at here is kind of just the standard backup, right? And as we talked about and John mentioned, right, we have grid, 200 amps coming into our meter. We got our disconnect, and then we're going to feed it all of that right into our grid port. In a grid up situation, all of those 200 amps will be able to pass down through that load, and we can dynamically control that. If we want, during certain times of the day, we can actually use and discharge the batteries to help support some of those home loads, maybe even potentially all of those home loads, so we're not drawing from the grid. Of course, we have solar down here that does or does not have to be there to be able to charge up the batteries in a grid down situation, or in a grid up situation. We charge up the batteries and cover home loads during the daytime and then discharge our batteries. With some of these new net energy metering policies, we're doing everything we can using the solar, using solar and batteries to not use the grid and not send back to the grid. And that's really what it's going to be key to some of these new net energy metering policies that I mentioned. Now, in this example, we have the generator feeding into the gen port. So again, there's a 2-wire signal to start that if the energy storage batteries are starting to go low, we can start up that generator and charge up the batteries. One line that is not on here, and I want to address, is a lot of generators, including ours, need not only to be able to send power out, which you see on these lines here, but also we need to be able to feed power to the generator to be able to keep the starting battery in the generator charged. And if we have any cold weather kits to keep the battery or the block warmers going. Additionally, those wires also let the generator know when grid is or is not present. And in a whole home backed up situation, we're going to land those conductors and that breaker in the only place there is a load center, which is in this one over here to the right. And we're going to talk about what you might need to do differently with that generator so that it will be able to start. Now, that gen port on a Solarc is capable of much more than just having a generator being fed into it. So there may be a reason why you want to have that generator port open. We kind of mentioned it earlier. You can use the generator port as a load out, as a smart load out, and that port can disconnect or connect loads based on the battery reserve levels of the battery. That's a great feature. It's really exciting to see that. Another reason you might want to have that gen port open is for AC coupling solar. Go ahead, John.
Yeah, that's where if you're not doing a generator on your site, then that is where you want to hook up an electric hot water tank, because that's where the load control side is free. You know, it will basically, what it will do is in a grid tied scenario, the electric, you have your hot water, and in an off grid scenario, it'll only operate that hot water tank during based on percent of during the day. So it's a great area to hook up a hot water tank. You could hook up an EV charger and kind of do a similar thing. but it's very versatile. So the point is, if you miss something on your design and you go into your project, that gen port gives you an extra tap to figure out, what you want to do with it. And on the generator point, I've talked with off-grid customers, and their concern during system operation is when they hear the generator running, they feel anxious because they know they're on a timer. Whereas when they're running with the battery and solar, they realize that they're in a healthy range. So that's where the taking care to power the battery with the site power rather than an internal battery, which is a feature you guys have. Not needing to exercise the generator to charge the what would otherwise be an internal battery, and also the optimizing of the runtime really comes into it. We've had customers who buy the Solarc and battery system just to improve the generator.
Yeah.
We have customers in Alaska where it's dark half the year, and for some reason they still like living there, and they charge, hook up the generator to the battery for generator, optimization and efficiency. So it's a very standard practice to add batteries to a generator system. And we tell the solar guys the same thing. Like, you need to think of yourselves as battery installers first, and then these additional accessories can add on and expand your project value.
Yeah, great point. Another reason, John, why I could think of you wouldn't land a generator on the gen port is if you want to have a much larger generator than what can be handled by the gen port. This this setup, though, I do see if you have an existing generator on site and an existing transfer switch, this may be kind of the best way to do it. You just leave the transfer switch in there. This is already being fed down, and you can have that easy kind of install. I know we're already about halfway through the hour, so let's keep moving.
Yeah. And before we do, I just want to say you could do two inverters in the gen port stacks. So the thing about Solarc is the design architecture is so flexible. It's hard to say this is exactly how you should do it, because the more you learn and become familiar with it, the more ways you'll figure out how to optimize it to get rid of balance of system material, because there's just so much provided inside the equipment that there's tons of stuff to think about if you really want to get into it. So the one line diagrams in our manuals are only examples, and
Yes.
there's lots of other things you can do.
Yeah, and I would encourage you to join some of John Solak University talks, or even at our Power Academy, where we spend a little more time diving into some of those specifics. I know you guys have a great team of sales reps. So does Briggs and Stratton, that can help walk you through. I'm not going to talk about all of what we're looking at now is the inside of a Solarc 15K. And for sake of time, I'm not going to run through all these different things. The one kind of I do want to call out, though, is our accessory kind of pinouts here. And there's a couple ones that I want to talk about as we're going to be thinking about how we want to wire up a 2-wire signal to start. And really, it's pins 7 and 8 here. This is where you're going to be able to send that signal to the generator to let it know to start up. Now, this is a normally open, and fortunately for us, Briggs and Stratton generators operate on a normally open gen start relay. There are some other companies that do a normally closed, and you may be able to get a device that can allow you to adjust that. So you come out of that Solarc when that 2-wire signal to start. We have two kind of types of models of generators. We have what we call the horizontal. Those are the larger size generators, and the verticals. Regardless, you're going to find pins 4 and 5, and that's where you're going to land that coming out of that Solarc into our generators, so that you can the generator knows when it's supposed to start and when it's supposed to stop. I mentioned earlier that the generator is being fed utility to keep the battery charged and keep any of those cold weather accessories. Typically, the generator also uses that grid signal to determine when there's been a loss of utility to know when to start up. But as I mentioned earlier, we're feeding this kind of grid or the power to the generator out of a backed up loads panel. So if the grid goes down, that backed up loads panel is not losing power, and the generator is going to think that the grid is still there. one adjustment we need to do is get into our generator, get into the controller, and disable what's known as mains monitoring so that the generator, if it sees the two-wire signal start, will still start up and run it when it's accordingly. Now, there are some settings that we need to change or at least pay attention to in the Solarc as well. And I will just say this, that there's a number of settings that need to be taken, that need to be adjusted in the Solarc programming. What I'm going to focus on in today's talk, just for the sake of time, what are the necessary settings that need to be done if you have a generator connected to the gen port? There's additional settings and considerations that need to be taken when you have a generator connected to the grid port that we're not going to dive into. Again, John has some great trainings on Solarc University that kind of dive into some more of those settings. One of the important settings is to tell the generator when you want it to turn on. Now, typically with a lot of energy storage systems, we always would choose a 20% state of charge, right? We don't want to drain the batteries all the way because we want to encourage or make sure we get a lot of cycle life out of the battery. And that's possible, but I would almost argue that you could even go down to 10. In fact, we can even go a little lower and still provide a lot of cycle life. So you're either going to use a voltage base setting, and you could find the corresponding state of charge to voltage in our manuals for any battery, I would assume, I would hope. But you could also use a percent charge, and that's going to be dictated about how you're using the Solarc. Another important one is the amount of maximum rate of charge of the batteries from the generator, right? So you don't want to overload a generator that may be on that generator port. Then so what we're telling the Solarc is we're telling when do you want the generator to start it, at what battery reserve level. And that's where you do this. Once that generator does start, it's going to charge up those batteries almost completely full. We're not going to float the batteries on a generator, but we're going to get them full. We're going to get them up to about 95% state of charge, and then we're going to shut that generator off. I will say this, that there is ways, if you're using a generator on a grid port, to actually dynamically adjust when and how much of a charge we put on the batteries out of a generator. Check out, again, some of John's talks on Solarc University to get into some more of those details. So one thing to keep in mind is a generator has an exercise cycle. We call it an eco size, and I could go into what that means. I will maybe here in a little bit, but you want to start the generator up occasionally. Now, there's a couple reasons why you might want to start a generator up. One is just to make sure that it works, right? And make sure that it does come on. And if it doesn't, right, it's going to throw a fault code and make sure you get a service person to come out. Another reason why you might want some generators to come on is so that it can charge up its internal battery. Like I said earlier, we're using a grid source to keep our battery charged. So we use our generator auto exercise, frankly, just to keep it, to make sure that it's going to work when you need it. Now, that can either be controlled out of a Solarc, or it can also be controlled on the controller inside the generator. For us, I would recommend probably just disabling the gen exercise cycle in the Solarc. How you do that is you just adjust the time to 0 and let the generator, the controller inside the generator, be responsible for that eco size. Another reason we start a generator without an outage is what's known as a burn off, and we do that biannually, where we run the generator for longer than just 30 seconds or 16 seconds to make sure it comes on and works. And we run it for maybe an hour, so we're kind of burning off anything that might be in that engine. You can theoretically force the generator to start to test it out. That's what you do with the gen force. And then another limitation is going to be able to limit the power drawn from the gen AC source here. John, anything to add?
No, not really. I mean, the gen force could be used to manually start the generator remotely. So if you do want to start up the generator from time to time, but maybe not on a weekly basis. Logging into the system remotely and using the function is one option.
Yeah, thank you.
And then the other was the small generators can be used as well. And I've always found it difficult to find small generators with a generator auto start function, but Briggs and Stratton may have some in their line.
Yeah, exactly. And we're going to talk a little bit about portable generators. Absolutely, portable generators do not. So to have that convenience, right, where you're not having to manually start and stop a portable is huge, right? You're taking, you don't have to monitor the state of charge. You can have that automatically started. Our smallest generator that can be automatically started is our 13K generator, one of that vertical units that I showed you there. So again, what kind of generators can be used? It has to be one that has automatic start with the normally open. And as I mentioned, it's important to understand that either the inverter or the generator can initiate that exercise cycle. And these portable, usually all the ones that do have the 2-wire signal to start are going to be approved for unattended operation, right? They have features in them that if it runs out of oil, it gets too hot, it starts to it's not firing, it'll shut itself off and protect it. I will, kind of a safety thing is that the generator may automatically start because it has that exercise function built into it without the generator or without the inverter calling for that. And then additionally, you can manually start or stop our generators from the controller in the generator. So we're gonna kind of transition over to some of the products really quick. And then we'll kind of wrap it up with some final thoughts and talk about some other future training. But we're really excited, Briggs Stratton, to be partnering with the Solarc. Again, what you're looking at is our 6.6 stacking battery. It's a quick install paired up with the Solarc inverter. So you're getting 20 kilowatt hours of storage, of energy. But what we've been able to do with some of this new generation of batteries is also have a very fast discharge rate, or a C rate. So with that Solarc 12K, I mean Solarc 15K, in a grid, in a no solar situation, it's capable of outputting 12 kilowatts. Well, our battery, this 6.6 with 3 battery stacks here, is capable of providing 14,000 watts continuous discharge. So if that Solarc is being called upon to start some loads, that the battery that's sitting there connected to it will be able to discharge itself quickly enough to help make sure that Solarc isn't being starved of power coming from the battery. Really excited to see the indoor-outdoor rating of the batteries and the inverter, so you can put it outside. I got a talk coming up, and I know, John, you've done some of that, and some of my inspiration from my talk is a lot of the building codes that are requirements that are coming along. I know a lot of us are really familiar with energy, the NEC, but when we start talking about building codes like parking bollards or drywall requirements or heat detectors, some of these other ancillary parts and pieces might add a lot of cost to the job. So by being able to put these batteries outside, you can avoid some of those extra costs. Some features of the 6.6 battery is the status LED lights. A lot of times back in our old off-grid days, John, we would go out to the power shack and look at the Trimetrics battery meter, and we could see what the state of charge of the battery was. We still have something similar, right? We have some LED lights that will indicate the 25, 50, 75, 100% state of charge. These lights can also indicate if there's a problem with the battery. The stacking nature of it. There's a lot of stacking batteries out on the market, but the ability to stack them not only physically, but also have both the communications and the power conductors being able to stack is accomplished with our rapid stack battery connectors. And I've heard from some of your colleagues, John, that looks matter. The look of a battery actually does matter to some people. And so we're really proud of how this battery looks. It's kind of flush mounted. It doesn't stick out very far. That allows you to kind of put it into some locations that you wouldn't otherwise be able to do. And just like having that little transfer time, looks can matter as well. Cycle life. So we talked about that earlier, right? Remember I said, oh, a lot of people always go to 20% stated charge. You can discharge these batteries down to 100% depth of discharge and still get a lot of cycles out of this, right? 6,000 cycles divided by 365 is something like, 16 years. So the difference between these two cycle lives is how quickly you charge the battery, can dictate whether or not you kind of shorten the life or use up the battery. But again, a lot of times you're not discharging, 0.5 discharge rate. That's 2C, right? You're charging or discharging the battery in 2 hours. Most people don't do that. And a lot of times you're kind of discharging the battery over a longer period of time. LFP, that was something that it refers to the battery chemistry, and that was something that Simplified Power has always been an innovator in. I do see a lot of other companies switching over to LFP, so it's not as big of a selling point as it used to be, but it's still something we leverage and we're going to use. Not to say that cobalt-based chemistries do have a time and place, maybe in mobile or those Vanguard batteries that I was talking about for your electric lawnmower that we're coming out with. But for stationary home storage, what we care about is safety and longevity, cycle life, and that's where we see it with the LFP technology. Mentioned it with indoor outdoor rated. Now, John, you had mentioned maybe we should just have a little extra space here, and I was kind of referring to having the gutter being a little extra long. But again, you mentioned with the homeowner on the looks. Go ahead, John.
Yeah, I wouldn't go that far. I mean,
Okay, okay.
you can always put a knockout in another gutter and
Yeah,
have it look nice, but getting it up off the wall, off the floor like that is allows you to put it in California sidewall garages.
yeah,
A couple slides back, I was just looking at the product and you were talking about the quality and the aesthetic and the look. And we don't have time to get into the details, but it is the difference between a American company creating the product versus a Chinese import, because the difference is what the customers are very important. Looks sells the system, whether the power lights go right to left or left to right, sells the system. On having a stackable battery, that connector, having it be the most solid as possible, your connectors better than others. And it shows that y'all have been making lithium batteries for as long as anyone in the industry, when you come out with a product like this.
yeah, yeah. Thank you, John. And it's always a shame to have a great looking system and then have to come along and go to PV Labels and buy a whole packet of labels and then sticker the thing up with all these red, maybe you need reflective labels. I will say this, that's why these are marketing photos and there's not a bunch of stickers on here. But this conduit here is not really going to fit the conductors, the 4-aught or the dual 1-aughts that you see on here as well. So I would expect something a little bit bigger there as well. Another thing is that a part that is missing out of here is what we know as energy track, and I'll talk a little bit about that. When somebody does, and this is important to mention, that when somebody does have a Solarc, they're going to have My Solarc app, and that's a great app that allows you to do a lot of controls with the Solarc, monitor the complete energy reserves, the power output, change some settings. But we are requiring an energy track app, and it has a little gateway that I would probably install right here next to the gutter. That's going to allow Briggs Stratton to do a lot of important things. One is being able to push firmware updates to the battery, be able to get more granular technical details on each of the battery stacks. So if there is a problem, our tech support will be able to remote in from the Briggs Stratton tech support office to take a look at that. Kind of the looks of it. One thing I do want to call out on this is we've changed the cell structure of the battery cells and changed the electrolyte that's inside the battery so that it becomes less viscous or less thick in cold weather. What that allows us to do is to be able to charge the batteries at colder temperatures. And that's really where we see this kind of charge temperature is usually where it matters most, as we're trying to force those lithium ions into that across that electrolyte. So a lot of our competitors don't have that cold weather capability. And if they do, they're using battery heaters, which uses energy. Now, if you are in a location where it does get colder than that, we do have some other options using some of our Boss cabinets that can have heaters. Here's this solar converter lineup. We're kind of going from smaller on the left over to larger on the right. I will say, kind of pointing out, one of the things we wanted to add in here is what's the rating of that generator port? And Briggs & Stratton absolutely makes a larger water-cooled generators that can do either three-phase 208 or three-phase 480 that can use a generator. We can supply you a generator that can be leveraged with that 30K or the 60K. John, anything to add to this slide here?
Well, for our commercial inverters, it's apparent that they're built off the same architecture as the residential. So, we've had these inverters, this product series goes back to 2018, and it's been installed in Alaska, it's been installed in Puerto Rico. So very extreme environments, and we haven't had any corrosion issues to my knowledge. And that's just one item you would think of when it comes to an outdoor rated inverter. So they're rugged.
What we've done is taking some of those batteries, energy storage batteries that we make here at Briggs & Stratton, and then kind of created some packages that kind of pair up with some of the Solarcs to make it a little simpler to position some of these. That being said, that you don't necessarily have to stick in each of these buckets here. And then keep in mind that some of these outages that a lot of people experience around the country aren't, excluding major events, aren't necessarily as long as people realize, right? A lot of times it's a tree falling on a power line in your neighborhood, or somebody crashes into a power pole, and the utility is able to send out some workers and get the power back up. So when we look at the average outage, it's not much more than a few hours in the country on average. And then so by positioning some of these hours of backup, it allows you to kind of give that peace of mind, or position that. And we looked at some of the average consumption usage across the country, and understand that when you're maybe using an 8K, you're not backing up the whole home. When you're going to do a 15K, you are backing up the whole home. And that's where these hours of runtime are coming from. And you can see that Energy Track app there in those photos. Keep in mind, we do have other batteries other than that 6.6 battery. These are batteries we've been making for over a decade now. The Phi, the Amplify, Outdoor Rated Simplify. And on the far right-hand side is our high voltage line. It's important to understand that Solar 30K and that Solar 60K, correct me if I'm wrong here, John, I think you need at least 150 volts on the battery, on the DC on the battery side, to get that inverter to wake up. So unlike the residential 48-volt batteries, where we always kind of wire them in parallel, what we're doing with our high voltage line is we're wiring them up in series, right, to build up that voltage, to provide the voltage necessary to get that this 30K or the 60K to come along. And these are each 4.3 kilowatt hours, and we can put them in these racks that you see here. Now, I apologize, John, for that picture of the older solar converter. But one thing before the 6.6 has even come out, this goes back years. We've been providing these access cabinets, and I get installers that still really like these. They don't want to put it in a garage. They don't want to put it on the outside of the house on a wall. What you come along with is this cabinet, this NEMA 3R rated cabinet. Put the Solarc in. Put some Amplify batteries down below. Each one of them is 3.8 kilowatt hours. And then using bus bars, using all the parts and pieces that come with these access cabinets, put together a quick system And these can be a great solution for somebody not wanting to put it onto a wall. Really quickly on generators, then we'll wrap it up. I know we're kind of coming up on time. Um, a lot of generators, they're called standby generators, right? A standby generator is a generator that's waiting for a utility outage, and then it'll start up if it sees a loss of utility. Now, there's different EPA certifications when you start to use a generator in what they call a non-emergency situation. So this is specific to off-grid systems, and also a demand response where certain co-op utilities can command your generator to come on to take over, to kind of remove that home from the grid when the utility deems it necessary, maybe in a time of high demand. So our 18, 22, and 26K generators do come with the certification for non-emergency use. Keep in mind the warranty changes a little bit from having kind of a 6-year warranty with unlimited runtime to a warranty more based on hours. This is the air-cooled lineup, right? We kind of started that 10 kilowatt generator that does not have 2-wire signal to start, 13 all the way up to our 26 air-cooled generators. Commercial generators, the water-cooled ones, that's why you see this big kind of thing, that's a big radiator over there, are available, plus our transfer switch. One thing I think I'm really proud of for Briggs & Stratton, what we've been able to do on the generator line is all of these if you go out and buy a 22K generator, that's 22K on propane. As soon as you go to run a 22K generator on natural gas, it derates. Ours don't. We've taken some steps. We've optimized the ignition timing, the coils, the intake manifold, the exhaust manifold, so that if it's a 22K generator, whether it's on propane or 22K on natural gas as well. Here's the commercial liquid cooled kind of lineup, and there's a lot of different options here. I'm not going to run through them all, but keep in mind that these can provide the 3-phase power necessary to run either a 30K or a 60K. Transfer switches, we've simplified some of our transfer switches into kind of a new core lineup that you see there on the right. And they're still available with us as well. John, can you use a portable generator and feed it into a Solarc?
Oh yeah, no, it's common. It's that's what customers for our initial customers with like 8K models were doing. The portable generator is a great solution to just have it there. Not all customers have the budget to do everything we would like them to do. And some customers have the need for a portable generator elsewhere on their property.
Great point.
So yeah, you can hook up a portable generator, manual start it. And I do think that manual start generators should be given more credit because of the limited number of times you would actually need to use them. And, most of the off-grid installers will know that having your customers do a few things manually might actually reduce your service calls rather than relying on automation. So it's a very good solution. Yeah.
Yeah, and I realize we only got 2 minutes, so I'm going to go quickly. Yeah, you're right. A lot of people buy a generator, they get all excited, they bring it home, put gasoline in it, and then don't use it for a year. The gas has gone bad. So I kind of like the idea of using some of these portables that run on a propane tank. And that way, when you shut the generator off, that fuel just kind of evaporates there. I like the twist lock on the outside of the house. I'm going to skip through some of these. This is talking a little bit about the placement of a generator. One of the biggest problems I see in standby generator installs is not the electrical install, is that you're not doing your fuel lines correctly and you're starving the generator of fuel. I want to spend a little time just kind of finalizing our thoughts here. The way I think of a Briggs & Stratton generator plus a solar converter with our battery, it's kind of like a hybrid car, right? You use the electrical batteries to kind of get you through, and then when you need it, the generator can come on. It's not like that full EV kind of, you get that range anxiety. And what I mean by the full EV is that it would be, say, a solar, our battery, and some solar, and then there's no sun. It's nighttime. So what you're doing is you're really kind of extending out the amount of time that you can go without having to run the generator. And it's pretty. This chart you see here is essentially the consumption of our generator at a certain load point, and the amount of fuel it uses. And with propane, I kind of mentioned this at the beginning, right? $2.40 a gallon. That I got that off of a government website, and you're running a generator, right? So we take that 20K generator, we run it for 1 hour, and it's using 3.75 gallons, right? That's where I came up with that $9. And Nathan, being a professor, probably would have wanted me to show my math here a little bit more. So I'll come back and adjust this. But if you run the generator at a quarter load, right, you're still using a gallon and a half at 239. So if kind of what I want to point out here is that if you're running it at half load, you're using 2.3 gallons, an hour. That number, if you double that, right, you're up above 3. So the idea, the kind of takeaway here is run the generator hard, reduce the amount of fuel, reduce the maintenance, reduce the fumes, reduce the noise that induces anxiety that John had mentioned out earlier, and provide the homeowners with a more resilient system as well. Please check out Solarc University. A lot of great stuff. I know, John, you do a lot of NABCEP courses as well, or earn those NABCEP courses. Power Academy, that's kind of our version. A lot of great stuff on there, not only on our energy storage, but a ton of stuff on generators as well. Maintenance. We have different types of forms as well. Thank you, everyone, for sticking with me a minute two over. We do have an installation qualification program. You can sign up for this, and you'll get some money back and get additional money back on your first install. NABCEP credits. Okay. You're here for NABCEP. Please email us at energystoragetraining@basco.com. That's energy storage training, Basco, that stands for Briggs and Stratton Company, .com, and I will issue you your NABCEP credits.
So Daniel, quickly,
yes, Nathan,
before
welcome.
we move on, Russ had said all of these portables still require a manual transfer switch to avoid backfeeding the grid, but we've talked about that before, and I think John Cromer can address that. John, do you want to speak to that briefly? I think that's not quite true.
There's a new kind of transfer switch, and sometimes the solar industry calls it a transfer switch, but it's really not. It's more like a contactor. It's a disconnect. So the term is a microgrid interconnection device, and that's on the grid side of the Solarc inverter. So it's built in. The Solarc will disconnect the grid during the power outage.
And that portable will not start feeding through the Solarc if grid is present, correct?
That's right. You would need to put a disconnect between the Solarc and the generator, but you don't need to put a transfer switch between the grid and the generator.
Right. Thank you. And that's it for questions.
Well, thank you, everyone, for attending. Again, if you're looking for NABCEP credits, please email energystoragetraining@basco.com. Everybody's going to get a link to the recording of this video. You're going to get a link to a survey. We'd love your feedback. Additionally, we'll be sending all the slide decks out as well. Thank you, John. Thank you, Nathan, for attending, and we'll see you all next time.
Thank you.